Problem F10.3. Determine the moment of inertia of the shaded area about the y-axis. So we want the shaded moment, the moment of inertia about the y-axis, which means that we are looking for pieces that are a certain distance away from the y-axis. Because of that, we are going to take this shape and divide it up into a bunch of vertical stripes. Why vertical stripes? Because each vertical stripe is the same distance away from the y-axis as all other points on that vertical stripe. So we can find the y component of the moment of inertia by taking the x value of that stripe, wherever that stripe is located, and dA would be the area of that thin little stripe. Now this thin little stripe we can approximate it as a rectangle that has a height of y, whatever y we get from this formula, and a width of dx. So we can say that dA is equal to y dx. Now if we take this equation and solve for y, we take the cube root of both sides, we see that y is equal to x to the 2/3 power. So dA, the area of one of these small stripes, is equal to x to the 2/3 power dx. Plug this dA into here, we get x squared times x to the 2/3. We can combine them and say that becomes x to the 8/3 power. Now for the limits of our integration, because we have already used this formula to determine the size of the stripes, we are only integrating along the x-axis, which means the realm of possible values goes from 0 to 1. So we're integrating from 0 to 1 of this formula right here. Now, may look ugly, but this is still a polynomial, so we can still use the polynomial rule. We add 1 to this power, and keep in mind, because it's x to the 8/3 power, adding 1 is essentially adding 3/3, and it becomes x to the 11/3 power. And then divide by 11/3, which is the same thing as multiply by 3/11. Next, include the bounds from 0 to 1. If we plug in 0 for x, we get 0. If we plug in 1 for x, we get 11/3. So the answer is 3/11. Pardon me. The answer is 3/11 meters to the 4th power. Now, as a note, we were a little bit lazy with our units, largely stemming from this equation not making sense without a constant value there. So we're going to have to make do. We use the ultimate units of meters to the 4th power.